back to outrageous acts of science. We're counting down skilled souls who nail whatever they attempt. Everything's up in the air now as we catch up with number 16. North Philadelphia, born and raised in a giant vase, is where he spent most of his days.
This is physics at its most mesmerizing.
Greg Kennedy is the only juggler on Earth to nail 9 balls of light in a gigantic cone.
This guy doesn't even like juggling, but no one will let him out of the cone.
We're in Philly to enter the cone zone and shed some light on Greg's captivating skills.
I've always liked to challenge myself. Some of the things you might see me do in the cone is not something that took a month or a year. I've been working on some of those patterns for a decade now. I'm coming up with whole new things that nobody ever dreamed of. And for me, that's part of being human, part of being alive.
Who wants to lift the lid on this bewildering ball show?
Greg's skill is in how he throws those balls. He doesn't let them bounce, but instead rolls them smoothly around the inside of the cone.
Once they're on the wall and traveling, the centrifugal effect keeps the ball stuck to the wall.
It's trying to travel in a straight line, but the shape of the cone is moving it in a curve.
And this means at all times the ball is pushing on the wall and the wall is pushing back on the ball.
So if I take a ball and I throw it horizontally, and with the right energy, it'll stay in a perfect circle. I can also do that down low, but I'll have to throw with a little less energy. I can take that ball and I can throw it downwards with a lot of energy, and it will come back up. I can also throw it upward, and it'll go down and back up.
But how do Greg's balls go down and back up again?
Each ball is being forced to follow a curved path, which means it's getting angular momentum.
Angular momentum is a conserved quantity. That means that unless some outside force acts on the balls, the angular momentum will remain the same.
Angular momentum depends on 3 things: the mass of the ball,
Its distance from the center of rotation, which in this case is the central axis of the cone, and how fast the ball is moving.
and if you change one of these things, the other 2 has to change so that the total is always the same.
Because each ball is making its way down the cone due to gravity, it means the tightness of its curve is getting smaller. That forces the ball to get faster just to keep angular momentum the same. The faster each ball gets, the greater the centrifugal effect acting upon it, which is pushing it outwards, but because it's in a cone, it effectively goes upwards.
It's circus with science.
Over time, as I gotten older, I figured out it was going to be better for me to continue juggling less with my body and a little bit more with my mind. My contribution at this point is actually expanding the realm of juggling and creating new concepts, and in a lot of ways, I think that's going to be my legacy.
Greg, you totally own the cone.